So it's good to be back, and today what we want to do is review in brief the segmentation activity. The goal was to watch a short video on how each of these commands work. It's a best practice to break up networks into smaller segments called segmentation or subnetting. We've covered that term before. CIDR is a useful method to accomplish this task. That's also something we have reviewed before. To view how many subnets are present between your system and a system on the UVI campus, enter one of the two commands below from a command prompt or terminal shell if a Mac. Now, what's implied here by this directive is that the command prompt is opened with what privileges? Anyone?
Administrative privileges?
Administrative privileges is correct. So if we open up a command prompt, or if you type in CMD, right? If you start typing CMD, let me close this and just search CMD. You'll see an option to run as administrator, or you can right click and run as administrator. And what you should see when it opens is the word administrator in the upper left corner. Both PathPing and TraceRT, sometimes called TraceRT, that's what the RT stands for, are designed to provide detail for each of the hops. So this is, the word hop is a term that's used to describe the travel of packets from one network segment to another. So if you have 4 hops, you have 5 network segments. You hop from the first to the second, second to the third, third to the fourth, fourth to the fifth. There are 4 hops working from the first network to the 5th network. As you traverse the networks, there's routing that occurs. And one of our main topics for this module is the idea of routing and how IP networking on layer 3 allows for larger networks. It's the smaller networks that are interconnected that make the internet. And of course, there are private internal networks that are local to an organization, but on the whole, the global network that we use every day is a series of smaller networks. And the packets that change or hop from one network segment to another on their route, notice the words I'm using here, along the route to their destination, part of the header is swapped out as they travel along the way. Some of that header is encapsulated and updated. So the header, portions of the header are updated along the way so that basically each of those network segments knows, is this a packet that belongs here or further out? And each of those network segments include in their configuration routes from one network to the next. PathPing, let's try this command. If I try PathPing -4 means use IPv4 146. Now let me ask a simple question. Was the video helpful in terms of explaining all of this or some of this?
Yeah, it was.
Now everybody's results may vary. So what you're going to get is a set of different results. So this is the host I'm on right now, sitting on 1.4. This is local internal. Then I'm in an intermediate network segment with broadband VI, and then broadband VI passes that packet onto their larger network, and eventually I end up outside. That's where you see broadband VI. Whenever you see the asterisks, that means that we're not getting results. after that point. So again, you may have a whole variety of different results, and it's okay if you don't see 249.101. It could be that the network security at UVI shows some of this, allows for some of this to display. And on the other hand, UVI may not. One of the interesting things you can do with each of these hops is to take a look at who owns it. Now, there's a domain name here, and we'll talk more about that in another module. But essentially, you see broadband VI, and then you see level3net.net. If you search to see who is, and I've copied that. If I go to a who is prompt, you can basically look up to see who the owner is, and sometimes that will match what you see on the screen, and sometimes it won't. So you may see that 208.49.194.161 broadband VI was purchased recently by who? Does anyone know?
Liberty.
No,
Liberty is correct. Thank you. Thank you. Yes, they were purchased by Liberty.
I thought they only got AT&T, but they bought a broadband VI too.
Well, AT&T had a division in Puerto Rico, and a group of entrepreneurs came together and decided that they would like to run AT&T Puerto Rico as a separate company. And so they basically gained ownership of the AT&T network in the Caribbean, in Puerto Rico and the Virgin Islands and elsewhere. And that's what became Liberty. That's my understanding of it. Now, some of you may know folks who work at Liberty, and the story may be a lot more complex, but essentially AT&T sold this portion of the network in their global network to corporate interests in the region, and they established their own network identity, and that's become Liberty. And then not too long ago, Liberty purchased broadband VI. So what do you do in a case where you have a blinking cursor and it's not going anywhere? It says computing statistics for 200 seconds.
Control C.
Yeah, we could hit enter. That's not doing anything. If I hit Control C, it's going to break out of there and give us a prompt back, and that's important. So if you wait a time, that's one thing that you can do. You can also capture the outcome of this command by putting it to a temp folder. So if I have this redirect symbol, a space, a right arrow, a right angle bracket, and then another space, and then I establish this as a destination for that output, I can take this output and capture it in the temp folder on the C drive in a file called pathping.txt, right? So, or you can just drag your mouse over it, right? And right click, and then open up Notepad, and then paste. Although that's not as efficient, sometimes you lose things in the translation there. So that's, any questions about the first command? Okay. So I'm gonna go ahead and run the second command, TraceRT -H 16. That's I think the number of 16 hops is the max, I think. -4 means use IPv4. And then I'll put 146.226.249.101.
Oh, question.
Uh-huh.
I guess maybe you said it already because you're talking about I guess the UVI campus wouldn't allow the route to be traced. I guess maybe it's related to that. Could it also be that the device that you're trying to ping or trace those hops to has their firewall on, so you can't establish that connection properly with them?
That's an excellent question. And to determine whether that's true, I'm going to do something right now to connect. Actually, that's not the one. It's either Sirius or Bellatrix. So this won't take very long. This is supposed to be one of the hosts that's used as a target. That's 101. Let's check the firewall and see whether or not we've enabled, and then we'll run the command again. That's how we find out. So that is a fair question, right? So I go into advanced settings. I can go into the inbound rules. What I'm looking for is echo, ICMP echo. This is the rule I'm looking for. So it's this one and this one. To answer your question, both of those are enabled. So if I ping, let me do this. Let me see if I can just ping 146.226, whoops, .249.101. Yeah, it could be that the campus is blocking ICMP requests, better known as ping. So ICMP is a network protocol that's used to verify connectivity with other hosts, and it can be used for malicious purposes. There's a thing called a ping of death. It's a denial of service attack where many machines ping a host all at once, and it overwhelms the network connection. Many firewalls will block that. Let me see if I can connect to another machine nearby. So this is Sirius, which is a system that's sitting in my office on St. Croix. And if the remote connection is successful, no, okay. So what I'll need to do is, do we have anybody that's sitting on campus? That's connected to the Wi-Fi on campus?
Yeah.
Oh, yeah.
Okay. Here's what we'll do. Can you share your screen, please? I mean, you might be connected to campus, but that if you're using a smartphone as opposed to a laptop, that might not be ideal.
I'm on my phone.
You're on your phone, okay?
Yeah.
Is there anybody that's connected to the campus network that's on their laptop right now?
Yeah.
Okay. Python, would you mind sharing your screen and then opening up a command prompt? There we go. Okay. So let's just enter IP config. Make sure you have a 146.226 address. We don't need all the information. Yeah, you're sitting on 146.226.106.52. That's great. Can you ping the default gateway? Let's try ping space 146.226.106.1. No, I'm sorry, 226. Yeah. There you go. 226.106.1. Yep. All right. So just hit your up arrow key and then use your backspace and substitute 249.101 for the 106.1. No. Backspace over the 101 and put 249.101 and hit enter.
Muted.
That is interesting. So there might be something going on with that host. If you can ping the gateway, but you can't ping 101, there could be some other security that's going on there. We'll take a look. So to answer your question, Milrain, there's additional assessment we can work to see if this goes. Now, I will tell you there's a, thank you, Byton, I appreciate it. Please send me email saying ping demo, okay? And I'll post additional credit for your willingness to be a demo today. And Milrain, so you've raised another question here, and what I'm going to do is check to see. It's called a pinhole firewall, okay? So one of the things that's really important to understand about firewalls and network security is that even though you enable a firewall, let me share my screen again. Even though you enable a firewall rule, it doesn't always mean that a firewall will let a ping through. And sometimes a general firewall doesn't do the general firewall rule doesn't do the trick. In some environments, you have to create what's called a pinhole rule. And I want you to see how that would work. So I want to be able to ping this host. And to make a long story short, even though the rule is enabled, there could be other network security that is preventing this thing from working. So one thing I want to do is identify my own IP address. And my own IP address, if I do an IP config, shows the internal address of my laptop. But my Wi-Fi router at the house, where I'm broadcasting from my home office today, that's translated into a public IP address. And what I want to do is determine my public IP address. Okay, so I'm going to ask, what is my IP address? And it should give me a result. So here is my public IP address. I could go to GRC Shields Up and probably get the same result, or network-tools.com, but I'm sitting at 208.49.194.161. Does everybody see that?
Yeah.
Okay. So on my remote system, I can add a new rule. I'm going to create a new inbound rule. And I'm going to allow ICMP to go through. It could be a program or it could be a custom rule. Let's do this quickly. Does anyone know what port ICMP uses?
No.
Does not use a port. That's what it's saying. I have seen a specific port. Port 7. It's used for echo service, UDP port 7. So I'm going to open a port for TCP and UDP for port 7. We'll explain more of this as we get into layer 4. But for now, I'm going to create a new rule. And I've started that process. So I'll create a new inbound rule. And it's going to be a port. And I'm going to it's UDP 7. And I'm going to allow the connection. And we're going to make that rule apply to any of the network profiles, domain, private, or public. And I'm going to call this pinhole ping, right? Just going to give it a good name to describe what it's doing.
So, oh yeah, so according to that description, it's literally just allowing pings to go through that specific port.
That specific port, but we're going to take it a little further. If I take this rule now and I open up the properties of the rule, I can define in the scope that it'll only allow this specific IP address. 208 dot, what do we say it was? What was my address? 49.194.161. 49.194.161. 49.194.161. So I'm only going to allow a ping request from this one host out on the public internet. I've created a pinhole firewall rule, which says I'm going to allow a ping request to come through. And I'm going to apply this. And then I should be able to, let's see if this allows me to do it again. And that's not it. I'll try one more thing. And then we'll go from here. So that didn't work. I'm going to delete that rule. I don't want a lot of extra rules just sitting around. I'll go ahead and create a new inbound rule. And we'll say a program. And let's see if we can, no, it's not going to work. Custom rule. All programs. Protocol ICMP. There we go. Does everybody see what I'm doing now? Which remote IP addresses add 208.49.194.101. Nope. 161. will allow the connection. Call this so that is active. It should be working. If this doesn't do the trick, then there could be something else in the mix that's preventing this, and it could be as simple as the security of the campus network has improved, and it won't allow pings from the outside to the inside. And it could be just generically blocked by the ITS department at UVI. So that is one possibility. Usually establishing a pinhole rule allows for that kind of thing to happen. In any case, what we've demonstrated here is how in Windows you can create a custom rule to allow a specific protocol, a specific port from a single IP address out on the internet. That's called a pinhole rule. We're going to try to, in module 6, when we get into special topics, we'll have the stage set where you can practice this, because it's a really good thing to do as far as keeping your network secure. So Milrain, I'm glad you asked the question, but we're going to come back to that at a later time, okay?
Yeah, sure. But does that mean that UVI campus, like their network is secure? Like it's top-notch secured?
Well, I would say that UVI makes a significant effort to secure their network and their public IP addresses. They've made some choices, or at least their predecessors made some choices, where they use public IP addresses on the local campus, and that's not a best practice. So there's a trade-off, but there's some economy that they gain from configuring their network address space in that manner. They do have adequate security. They could do some things to ratchet that down further. And that's the answer I'm going to give at this point. So what you see here from TraceRT, can everybody see my screen?
Yep.
Yeah.
One of the things that you'll find is that different network tools will provide different levels of access, or different amounts of details. So even though the PathPing didn't provide past a point, we lost it past the broadband VI section and the level 3, we didn't get any further. It died. TraceRT or TraceRoute was able to get a little further to ampath.net, and then from there the request timed out. So that's something that you see consistently with network utilities and troubleshooting tools, is that it's a combination of tools that you often need to utilize to get different pieces of the troubleshooting puzzle. And the important thing to understand is that you often have network packets that traverse from one segmented network to another. This is a private internal for broadband VI, and then the public network for broadband VI. And that as the packet travels, that there's additional encapsulation that happens along the way. And it's that process that delivers an IP packet across network segments using frames, and it's encapsulated in those frames and passed along with so many hops, right? If we had used something other than 16, you might have seen request timed out, and if I had used 20, we might pick up more detail further on. And so that's something I'm going to try right now just to see what happens. And see if changing this number to say 24 produces more detail after the dead zone. But I'm not going to spend the rest of the time waiting to see what happens. We'll come back to that in a moment. One of the things we wanted you to do, though, was to try each of those tools and to see what results you would get by pointing to those two different targets. And just to understand how so many network segments between your house and the UVI campus exist, right? And in previous seasons, students were able to count the number of network segments between their own home network and the UVI campus. You know, and the results vary. If you're sitting on St. Thomas versus St. Croix, the local network providers have a different configuration. In Mac systems, the command is called TraceRT instead of TraceRT. And that's an important distinction to note if you're using Linux. That's also true. The command is TraceRT instead of TraceRT. But a lot of technical people call this TraceRT, even though it's TraceRT. The important thing to understand is that a lot of similar utilities have slightly different names, and you have to know that they also have different switches, and that's part of the challenge. Certainly, one of the most important aspects of network security is keeping a record of the output. So one of the best ways to gauge network security is to see what changes occur over time. And from last year and the year before, I would have a pathping.txt output that differs from what I'm seeing here. And that would help me understand, okay, here's what's happened in between. And it won't shock me if we go 20 and it still says request timeout. We might get more detail, we might not. So this is a good idea that some of the network segments have additional security, and then the packet travels a little further and it's able to pick up more information. Let's segue into our content review. So in module 3, the goal is to, after a brief refresh of IP networks and CIDR, we want you to understand how to scale the network and to perform subnetting, and then use some simple tools to explain how the packet travels between segmented networks. Before our break, we were almost finished with our review. We talked about subnets. And by the way, we're 2 minutes away from finishing here, so just bear with me. In our module 3 study guide, we were showing you, this should be a familiar site. Does everybody see this?
That's
Yeah, we
what
can
we
see.
did like before spring break, right?
Yes, this is what we did before spring break. So if you have a /24 network and you need to conserve the use of network addresses to support more networks, use network address space more efficiently, you can take a /24 network and increase the subnet mask so that it's a /28 instead. That's a mask increase of 4 ones. So instead of 24 ones, it's 28 ones. The number of networks you can build is 16. So there are 16 subnet multiples or CIDR multiples from that original address range. And this is one of the ways that we conserve scarce public IP address space right now. Remember that as you increase the number of networks, you decrease the number of possible hosts in each network. You always have to subtract 3 from the total number of network addresses available. And in this case, if I increase by 4 that gives me 16 network addresses, but the first network address is reserved to identify the network. So the network ID, if I was using 192.168 as an example, 192.168.1.0 is the first network, but 192.168.1.16 is the second network. 192.168.1.32 is the third network, right? 192.168.1.48 is the fourth network, and so on. I have to have a gateway to get out of that network. So that's the second IP address I take up. I also have to have a broadcast address for each of those addresses. We called out the idea that there's a pattern here. So the broadcast address is one less than the network ID of the next network. What we're going to do now is stop. And on Friday, we're going to take up supernetting. We're going to work in reverse. What do you do if you have smaller networks you need to combine to create a larger network? And we'll complete the rest of the content review in the study guide in our module. So basically, what you'll need to do before we begin on Friday is finish reviewing the rest of the study guide so that we can make quick work of the remaining sections. Most of this is a recap of what we just explained. But there's some interesting material about IPv6. And that's, we want to give you some basics about IPv6. That's the other method that's used to conserve scarce resource address ranges on a network. The new version of IP is what we'll cover on Friday. So be sure that you're here. In any case, we want you to become familiar with this idea. When we talk about the encapsulation, though, this is this diagram in particular on slide 393. You want to take a closer look at that because it shows how packets are passed between the networks and routers. So that's just the headers change along the way as it's passed. The IP packet header that includes the destination, the final destination does not. That's how the IP packet knows eventually how many hops to go where to its final, where it's supposed to arrive, right? So your final destination where that packet is supposed to arrive always has the destination IP address burned into the header of the IP packet, even though the frames change from hop to hop. All right, we'll stop here and we'll see you on Friday. Thanks for joining us today and welcome back. Are there any questions or comments or concerns you'd like to ask based on the material we reviewed today? If you haven't completed the assignment, please go ahead and finish that and get it in so that when those are scored, you can post credit for it. Thanks for joining us today.